Welcome to this video. In this video we want to look at the first order reaction calculations under the topic chemical kinetics. The question that we have is the conversion of cyclopropane to propane in the gas phase is a first order reaction with a rate constant of 6.73 times 10 to the power negative 4 second to the power negative 1 at 500 degrees Celsius. So we have how the reaction happens. We have this description of how the reaction happens. So the first question that we want to calculate is, if the initial concentration of cyclopropane was 0.25 m, what is the concentration after 8.8 minutes? The B, how long in minutes will it take for the concentration of cyclopropane to decrease from 0.25 m to 0.15 m? The last question we'll answer is, how long in minutes will it take to convert 74% of the starting material? So let's start with the first question. The first question is asking us to find if the initial concentration of cyclopropane was 0.25 m. What is the concentration after 8.8 minutes? Now, before we can start solving this question, we need to remember this general equation. This is a general equation for the first order reactions. So as a chemistry student, you need to know this equation. Now, after we know that this is the equation for the first order reactions, where the natural log of the concentration at a given time is equal to negative Kt plus natural log of the initial concentration. So what you can see is, from our question, we have the K value, that is the rate constant. We also have the time, that is 8.8 minutes, and we have the initial concentration. So basically they are asking us to find what is the concentration at that time. So if we look at this question, when you look at the K value that has been given, it has the power second to the power negative 1. That is the unit of the K value. And in our question, the time is in minutes. So the first thing we need to do then is to change the time, which is in minutes, to take it to seconds. So how do we do the changing? We are saying basically we just need to multiply the 8.8, multiplying it with 60 seconds. Then we get the answer, that is 528 seconds. So if the K value was in minutes, then we would have had no need of converting the time. Now, because the K value is in seconds, we want to convert the time to seconds so that we have uniform units. So that now that we have 500, rather the time, which is 528 seconds, we can plug our values that we have in the equation. The K value that we have been given is 6.7 times 10 to the power negative 4. Then our time, it is 528. Then the initial concentration is 0.25. So now that we have the second, that is 528 seconds, let us plug the values that we have in the equation. The K value given is 6.7 times 10 to the power negative 4. The time is 528 seconds, and the initial concentration is 0.25. So how do we put these, or how do we punch them on the calculator? So on the calculator, we'll start with open bracket. So the first values, they are multiplying, so we'll put them in one bracket, that is negative 6.7 exponent negative 4. It is multiplying by 528, then close bracket. Then we are adding this to the natural log of 0.25, close bracket, then we close all the values. So after we punch the equal sign, we'll find that the value that we have for the numbers that are this on the other side, it is negative 1.74. So this is the negative 1.74 which we have here. Now we need to find the exponent of this, which is the opposite of the natural log. So what are we going to do on the calculator? So the opposite of the natural log, will say the shift E. This is to the power of the answer that we have now. So it will give us now the 0.178, which is the one we have here. So the 0.178 becomes the concentration after 8.8 minutes. So let's go to question. This question is asking us the time in minutes that it will take for 0.25 m to reach 0.15 m. Now we have this equation, the very equation we used in the first question. We have just made the natural log the subject of the formula there. So if we plug in the values, we have 0.15 as the numerator, then 0.25 as the denominator, which is the initial concentration. Then we have the K value, which is 6.7 times 10 to the power negative 4. And the question is asking us to find T. So the T which we'll calculate here will be in seconds. Now they have asked us to give the answer in minutes. So we'll eventually have to convert that seconds to minutes. So let's punch this on the calculator and see how we'll get the answer. So we'll start with 0.15 divided by 0.25. We'll get the answer. So this 0.6 need to be, this is the natural log. So the natural log of 0.6, then the natural log of answer. The natural log of answer will give us negative 0.51. So this negative 0.51 should be divided by K. So K is negative 6.7 exponent negative 4. Then we'll get that is 762 seconds. So 762 seconds, we need to convert it in 2 minutes. So if we convert it in 2 minutes, we'll say divide by 60. Then we'll get 12.7 minutes. So if you round off the 12.7 minutes, you'll basically get 13 minutes. So from this question, we are simply saying it will take 13 minutes for the 0.25 to reach 0.15 m. Let's go to question C. Question C is asking us how long in minutes will it take to convert 74% of the starting material. Now, here we need to do some analysis. If 74% of the starting material has been used, then we are simply saying the starting material was 100%. So if the starting material was 100%, then 74% of it has been used. So if you get the difference, you will find that 26% of the starting material has remained. Now, if 26% of the starting material has remained, then the 26% becomes the percent at a given time that we have been asked. Then the starting material is 100%. So if we say the starting material is 100%, then the percentage that is remaining is 26%. Then we are simply saying we'll have 26% divided by 100%, that is in terms of concentration. Now, if you reduce this further, you are simply saying it is same as 0.26 divided by 1. So the 0.26 divided by 1 will now be the ratio that will be used in our calculation. So at 75% of the starting material has been used, 26% of it is remaining. So we'll use the 0.26 over 1 as the fraction in our mathematics. So now that we know the fraction that we'll use, so that's the one we have used, the 0.26 here, and 1 as a fraction. Then remember the K value is still 6.7 times 10 to the power negative 4. Then we are asked the time it will take for 75% of the starting material to be used. So let's see how we'll punch this on the calculator. So on the calculator, we'll say 0.26 divided by 1, we'll get 0.26. So the natural log of the answer, which is 0.26, we are getting negative 1.34. So this will be divided by the K value in negative, that is negative 6.7 exponent negative 4. We are getting 2010 seconds. 2010 seconds. So for this to be converted in 2 minutes, we need to divide this by 60. Then we convert it into minutes. So the minutes will be 33.5, which is basically, you can say 33 or 34, you will be marked. So it will take 34 minutes or 33 minutes for this reaction to use 75% of the starting material. So hope you have followed how we use this formula when you are calculating the chemical kinetics in the first order. So look out for how we use the half-life for the first order, and please don't forget to subscribe to my YouTube channel, Clopas Zulu, for this and more videos.